Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following geometry of 2D shape question focusing on similarity. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. We have in the diagram below, ABCD is a square with sides 9 centimeters in length and the line BE is perpendicular to the line EF. The first part of the question says, show that the angle F1 is equal to A if the angle E1 is equal to A. So I'm going to mark that in the diagram as shown, such that if I consider the triangle EDF, I'm going to extend the line ED to A, and I'm considering the triangle EDF. Note that the angle highlighted as shown, that's AEF, is equal to the sum of the opposite interior angles of the triangle. I'm using the dot. So if I state that, I have AEF angle is equal to angle D plus angle F1. And the reason being, external angle of a triangle. So therefore, we've been told that the angle E1, that's A, so I'm going to add that to 90, which means this angle is 90 degrees as shown. So I have A plus 90 degrees is equal to the angle D. Because we've been told that that is a square, the angle at D will also be 90 degrees. So we have 90 degrees plus F1, which is unknown. So note that we have 90 degrees on both sides, so I can take that out. So on my left hand side, using the balance method, I subtract 90, and also on my right hand side, I take out 90. On my left hand side, I'm left with A equals, because this cancels, and also on my right hand side, 90 minus 90 is 0, so that's A equals F1. So I've been able to show that F1 equals to A from the first part of the question. The second part of the question says, prove that triangle ABE is similar to triangle DEF. To prove the similarity, I'm going to start by drawing out the two triangles. That's triangle ABE and DEF. So I start with the first one. That's my triangle ABE. I have A, B, and E. I'm going to fill in the values given. Because it's a square, the angle at A is 90 degrees. We've been given E1 to be A, and then we're given my side AB, that's 9, as shown, 9 centimeters. Then I'm going to draw the second triangle. It's smaller than the first one. That's triangle D, E, and F. The angle at D, because that is a square, we have that as 90 degrees, as shown. And note that we've been able to prove that F1, which is equal to A, is equal to E1. So I have the angle at F equals to A. So therefore, going to our proof, we have the angle A that's equal to the angle at D, and that is equal to 90 degrees. That has been given in the question because we were told that ABCD is a square. Also, we're able to prove that the angle E1 is equal to the angle F1, and that is equal to A. We have been able to prove that from the first part of the question. And therefore, if you have two triangles with two angles exactly the same, then therefore the third angle will also be the same. So we have therefore the angle at B will be equal to the angle at E. And because all the angles on the first triangle is equal to all the angles in the second triangle, we have this triangle ABE is similar. We're going to use the symbol for similarity. We have the three lines parallel to each other as shown. That's similar to triangle DEF. And the reason for the similarity will be all the angles are equal, or we could say that is equiangular. Then we go to the third part of the question, which says, show that the area of triangle EDF is equal to x in bracket 9 minus x all squared divided by 18. So I'm going to start by stating that the area of triangle EDF is equal to the formula for finding the area of a triangle, half times base times the perpendicular height. Now, if I look at the triangle EDF using the diagram from the previous question, we are given DE to be 9 minus x. So I'm going to write 9 minus x here. I have the angle at F equal to A. So therefore, I start with taking my DE equals to the base, which is B, and that is equal to, if I look at the question, that's 9 minus x, all in centimeters. And if I look at my perpendicular height, I'm going to use DF as my perpendicular height. So DF is equal to height, that's my h, and that is equal to, it's unknown. So using my proportional sides, because I've been able to prove in the previous question that the two triangles are similar, so therefore to find the length DF, I'm going to state that the side AB from the first triangle divided by DE from the second triangle is equal to the side AE from the first triangle divided by the side DF from the second triangle, and that is the proportionality. So therefore, AB, that's 9, divided by DE, that's 9 minus x, equals AE, A is x, divided by DF, that's the unknown side. So using cross multiplication as shown, I have that as 9 times DF is equal to x multiplying 9 minus x. So therefore, dividing both sides by 9, as shown, I have therefore the side DF is equal to x in bracket 9 minus x divided by 9. Now that I have all the sides complete, I can go back to the area, so that my area of triangle E, D, and F equals half times the base. The base is my DE. I'm going to put that in the bracket. That's 9 minus x times the perpendicular height. That's my DF. And I have that as x in bracket 9 minus x divided by 9. So therefore, that is equal to, for my numerator, I have x in bracket. I'm not going to expand that. 9 minus x twice, so that's squared, divided by 2 times 9 for my denominator, that's 18, and that will be in square centimeters. So I've been able to show that the area of EDF is shown as given. Thanks for watching. Bye.